What's going on? What's going on? So, I am going to be working at a job that's going to require me to use this Snowflake platform, which is a data cloud platform. And I want to go in knowing the most that I can. So, I'm going to read the docs. I don't know how far I'm going to make it in, but I'm going to try to dedicate a significant amount of time to it. So, just going to jump right in. Getting started. Before you begin, a comprehensive guide to getting started with Snowflake and making the most of its features and benefits. Basic information. Let's go here. After your Snowflake account has been provisioned, you can access Snowflake using any of the following methods: browser-based web interface, SnowSQL, the Snowflake command line client, applications developed with Snowflake connectors and drivers, and third-party client services and applications. See Connect to Snowflake. If you do not have an account yet, you can sign up for pricing, for details. So I already made a free account. Browser requirements. Got you. I'm gonna assume that I'm okay using Arc browser because it's Chromium, but that might be a problem that I don't want to deal with, but we'll see. Note, Snow site supports a different set of browsers and minimum versions. For details, see Getting Started with Snow site. Tip, Snowflake recommends using Google Chrome. Other browsers have not been tested as extensively as Chrome and may exhibit some unexpected behavior. We'll deal with that when we come to it. SnowSQL OS platform requirements. SnowSQL CLI client can be installed on the following platforms. For more details, okay. Logging in. You can log into Snowflake in many ways. If you're getting started with Snowflake, start by using SnowSite or SnowSQL, the command line client that you can download. After you get comfortable using Snowflake, you can explore connecting to Snowflake with other methods. Your Snowflake account identifier. All access to Snowflake is through your account identifier. Signing in using SnowSite. You can access SnowSite over the internet or using private connectivity to the Snowflake service. Using the internet to access SnowSite over the public internet, do the following in a supported web browser. Let's see, is this supported? Okay, cool. Provide your account identifier. So I'm already signed in. Sign in. You can also access that. So using private connectivity, which is not what I'm going to do right now. I'm using the internet. Okay. So SnowSite quick tour. Let's put these side by side. In SnowSite, sorry for chewing gum, I'm sorry. In SnowSite, you can perform data analysis and engineering tasks, monitor, query, and data loading and transformation activity, explore your Snowflake database objects, and administer your Snowflake database, including managing the cost and adding users and roles. SnowSite lets you build, test, and deploy Snowpark Python worksheets, write queries in code, and take advantage of autocomplete for database objects and SQL functions in worksheets. Organize worksheets into folders, share worksheets and dashboards with other users, visualize worksheet results in charts and dashboards, create and manage database objects such as databases, tables, stages, file formats, and more, manage costs and set budgets, review query history and data loading history, see task graphs and run history, debug and rerun failed task graphs, monitor dynamic table graphs and refreshes, manage and create Snowflake users and roles, and visualize a hierarchy of roles in their grants. Perform data governance tasks like masking data, adding policies, and reviewing the governance of your data. Write SQL and Snowpark Python code and worksheets. Worksheets provide a simple way for you to write SQL queries, DML and DDL, see the results, and interact with them. With a worksheet, you can do any of the following: run ad hoc queries and other DDL, DML operations, write Snowpark Python code in a Python worksheet, review the query history and results of queries that you executed, examine multiple worksheets, each with its own separate session, export the results for a selected statement while results are still available. So here we see worksheets. If I go to my projects worksheets, so in this it's an example. Here they have some preloaded ones because I set up that option when I made the account. And if I click on, let's say, this first one, and in here they ran a simple SQL statement. This one has some preloaded stuff, but it's okay for now. Visualize query results with charts and dashboards. When you run a query in Snowsight, you can choose to view your results as a chart. You can also create a collection of charts as a dashboard, allowing you to review your data more easily. Dashboards provide flexible collections of charts arranged as tiles. Dashboard charts start with SQL to generate results and associated charts. You can share these charts with others, modify the charts, and display them as dashboard tiles. So here, if I come back out here and I click dashboards, if I were to set up a dashboard, I could see something like in this example, they have groceries with this bar chart. To learn more about charts, see that. Explore and manage your database objects. You can explore and manage your database objects in Snowsight as follows. Explore databases and objects, including tables, functions, views, and more using the Database Object Explorer. Create objects like databases, tables, file formats, and more. Search within the Object Explorer to browse database objects across your account. Preview the contents of database objects like tables, and view the files uploaded to a stage. Load files to an existing table or create a table from a file so that you can start working with data in Snowflake faster. So here, databases. We have some databases. Share and publish data products. Collaborate with users in other Snowflake accounts by sharing data and application packages with them or publishing those data products on the Snowflake marketplace. When you share or publish data products with a listing, you can use auto-fulfillment to easily provide your data products in other Snowflake regions. As a consumer of data, you can access datasets and application packages shared with your account or published on the Snowflake marketplace, helping you derive real-time data insights without needing to set up a data pipeline or write any code. So in data products, you have a marketplace with a bunch of some products and data. Monitor activity in Snowsight. You can monitor and view query details, explore the performance of executed queries, monitor data loading status and errors, review task graphs, and debug and rerun them as needed. You can also monitor the refresh state of your dynamic tables and review the various tagging and security policies that you create to maintain data governance. So in monitoring, we have query history. We can see all of our previous queries. Perform administrative tasks in Snowsight. Admin pages let you understand Snowflake data use, manage warehouses, monitor resources, manage users and roles, administer Snowflake accounts, and more. So under admin, cost management is what's selected. We have warehouses, etc. Get account information and update your user profile from the account menu. Select your username to open the account menu. From the account menu, you can change your active role, set your email address for notifications if you're an account administrator, manage and update your user profile, switch languages for the user session when additional languages have been enabled to your account or for your account, file support cases and access the Snowflake documentation, determine the organization, edition, cloud platform, and region of the current Snowflake account, access the account identifier and account URL, switch Snowflake accounts. If you have access to multiple accounts, open Classic Console, sign out, close your current session, and exit. For more details, you could go there, and we will. I'm not going to watch those videos. I'm just going to go to the next section. So I wish that there was a simple button here, but it's okay. Let's separate these. Come here, concepts. So, introduction to Snowflake. These topics introduce the Snowflake architecture and basic features, key concepts in architecture, overview of Snowflake architecture and basic concepts, supported cloud platforms, overview of the cloud computing platforms on which Snowflake is offered, supported cloud regions, description of the different cloud platform regions in which Snowflake is offered, Snowflake editions, description of the services and features included with each edition of Snowflake. Sorry, I just saw a pop-up, which means stop listening to me. Snowflake releases, description of the Snowflake release process and instructions for requesting 12-hour early access for Enterprise Edition and Business Critical Edition accounts, or 24-hour early access for virtual private Snowflake VPS accounts, overview of key features, list of key or major features in the current release of Snowflake, overview of the data lifecycle, introduction to the main tasks and corresponding SQL commands for getting your data into Snowflake and then using it to perform queries, and other SQL operations, continuous data protection, introduction to the powerful and unique features that Snowflake provides for ensuring your data is protected, secure, and available, regulatory compliance, description of the major regulatory compliance standards Snowflake meets to ensure the highest levels of data assurance, security, and governance for data in Snowflake. So architecture, key concepts in architecture. Snowflake's data cloud is powered by an advanced data platform provided as a self-managed service. Snowflake enables data storage, processing, and analytic solutions that are faster, easier to use, and far more flexible than traditional offerings. The Snowflake data platform is not built on any existing database technology or big data software platforms such as Hadoop. Instead, Snowflake combines a completely new SQL query engine with an innovative architecture natively designed for the cloud. To the user, Snowflake provides all of the functionality of an enterprise analytic database, along with many additional special features and unique capabilities. Data platform as a self-managed service. Snowflake is a true self-managed service, meaning there is no hardware, virtual or physical, to select, install, configure, or manage. There's virtually no software to install, configure, or manage. Ongoing maintenance, management, upgrades, and tuning are handled by Snowflake. Snowflake runs completely on cloud infrastructure. All components of Snowflake's service, other than optional command line clients, drivers, and connectors, run in public cloud infrastructures. Snowflake uses virtual compute instances for its compute needs and a storage service for persistent storage of data. Snowflake cannot be run on private cloud infrastructures, on premises, or hosted. Snowflake is not a packaged software offering that can be installed by a user. Snowflake manages all aspects of software installation and updates. Snowflake architecture. Snowflake's architecture is a hybrid of traditional shared disk and shared nothing database architectures. Similar to shared disk architecture, Snowflake uses a central data repository for persisted data that is accessible from all compute nodes in the platform. But similar to shared nothing architectures, Snowflake processes queries using MPP, massively parallel processing compute clusters, where each node in the cluster stores a portion of the entire data set locally. This approach offers the data management simplicity of a shared disk architecture, but with the performance and scale out benefits of a shared nothing architecture. So here we see database storage, query processing with virtual warehouses, and cloud services, authentication and access control, infrastructure manager, optimizer, metadata manager, and security. Snowflake's unique architecture consists of three key layers: database storage, query processing, and cloud services. Database storage. When data is loaded into Snowflake, Snowflake reorganizes that data into its internal optimized, compressed columnar format. Snowflake stores this optimized data in cloud storage. Snowflake manages all aspects of how this data is stored. The organization, file size, structure, compression, metadata, statistics, and other aspects of data storage are handled by Snowflake. The data objects stored by Snowflake are not directly visible nor accessible by customers. They are only accessible through SQL query operations run using Snowflake. Query processing. Query execution is performed in the processing layer. Snowflake processes queries using virtual warehouses. Each virtual warehouse is an MPP, and again that's massively parallel processing. So where was I? Each virtual warehouse is an MPP compute cluster composed of multiple compute nodes allocated by Snowflake from a cloud provider. Each virtual warehouse is an independent compute cluster that does not share compute resources with other virtual warehouses. As a result, each virtual warehouse has no impact on the performance of other virtual warehouses. Cloud services. The cloud services layer is a collection of services that coordinate activities across Snowflake. These services tie together all of the different components of Snowflake in order to process user requests from login to query dispatch. The cloud services layer also runs on compute instances provisioned by Snowflake from the cloud provider. Services managed in this layer include authentication, infrastructure management, metadata management, query parsing and optimization, access control. Connecting to Snowflake. Snowflake supports multiple ways of connecting to the service: a web-based user interface from which all aspects of managing and using Snowflake can be accessed, command line clients, e.g. SQL, which can also access all aspects of managing and using Snowflake, ODBC and JDBC drivers that can be used by other applications, e.g. Tableau, to connect to Snowflake, native connectors, e.g. Python, Spark, that can be used to develop applications for connecting to Snowflake, third-party connectors that can be used to connect applications such as ETL tools, e.g. Informatica, and BI tools, e.g. ThoughtSpot to Snowflake. Supported cloud platforms. Snowflake is provided as a self-managed service that runs completely on cloud infrastructure. This means that all three layers of Snowflake's architecture, storage, compute, and cloud services are deployed and managed entirely on a selected cloud platform. A Snowflake account can be hosted on any of the following cloud platforms, the three major ones. On each platform, Snowflake provides one or more regions where the account is provisioned. If your organization's other cloud services are already hosted on one of these platforms, you can choose to host all your Snowflake accounts on the same platform. However, you can also choose to host your accounts on a different platform. Note, the cloud platform you choose for each Snowflake account is completely independent from your other Snowflake accounts. In fact, you can choose to host each Snowflake account on a different platform, although this may have some impact on data transfer billing when loading data. Pricing differences in unit costs for credits and data storage are calculated by region on each cloud platform. For more information about pricing as it pertains to a specific region and platform, see the pricing page. Data loading. Snowflake supports loading data from files staged in any of the following locations, regardless of the cloud platform for your Snowflake account, and that's internal, i.e. Snowflake stages, and then Amazon S3, Google Cloud Storage, Microsoft Azure Blob Storage. Snowflake supports both bulk data loading and continuous data loading, Snowpipe. Likewise, Snowflake supports unloading data from tables into any of the above staging locations. Note some data transfer billing charges. Got you. High Trust CSF certification. The certification enhances Snowflake's security posture in regulatory compliance and risk management and is applicable to Snowflake additions that are business critical or higher. Partner applications. Many partner applications work with Snowflake accounts. Current limitations for accounts on GCP. Don't need to worry about it because I'm focusing on AWS. Current limitations for accounts on AWS. We strive to provide the same Snowflake experience regardless of the cloud platform you choose for your account. However, some services and features are currently unavailable or have limited availability for Snowflake accounts hosted on AWS. Access to external network locations. Access to external network locations from UDF and procedure handler code is currently not supported in the Gov region. Current limitations for accounts on Azure. We strive to provide the same Snowflake experience regardless of the cloud platform you choose for your account. Oh, got you. So, on to cloud regions. Supported cloud regions. This is pretty straightforward. So, additions, releases, and features. Snowflake offers multiple additions to choose from, ensuring that your usage fits your organization's specific requirements. Each successive addition builds on the previous addition. Got you. And sorry. Note, the Snowflake edition that your organization chooses determines the unit cost for the credits and the data storage you use. Other factors that impact unit costs are the region where your Snowflake account is located and whether it is an on-demand or capacity account. On-demand, usage-based pricing with no long-term licensing requirements. Capacity, discounted pricing based on an upfront capacity commitment. Overview of editions. There's the standard edition, which is the introductory level offering, providing full unlimited access to all of Snowflake's standard features. It provides a strong balance between features, level of support, and cost. Enterprise edition provides all the features and services of standard edition with additional features designed specifically for the needs of large-scale enterprises and organizations. Business critical edition, formerly known as enterprise for sensitive data, offers even higher levels of data protection to support the needs of organizations with extremely sensitive data, particularly PHI data, that must comply with HIPAA and high trust CSF regulations. It includes all the features and services of Enterprise Edition with the addition of enhanced security and data protection. In addition, database failover/failback adds support for business continuity and disaster recovery. Note, as required by HIPAA and high trust CSF regulations, before any PHI data can be stored in Snowflake, a signed business associate agreement must be in place between your agency, organization, and Snowflake Inc. Virtual Private Snowflake VPS. Virtual Private Snowflake offers our highest level of security for organizations that have the strictest requirements, such as financial institutions and any other large enterprises that collect, analyze, and share highly sensitive data. It includes all the features and services of Business Critical Edition, but in a completely separate Snowflake environment, isolated from all other Snowflake accounts, i.e. VPS accounts do not share any resources with accounts outside the VPS. However, you may choose to enable data sharing with non-VPS customers. See support for auto-fulfillment in virtual private Snowflake for more details. Note: to access your account, you can use an account identifier that specifies your organization name and account name. If you instead choose to use an account locator as the account identifier, note that the account locator for VPS accounts uses a different format than the accounts for other Snowflake editions. For details, see finding the account locator format for VPS account, feature addition matrix. The following tables provide a list of the major features and services included with each edition. Note, this is only a partial list of features. For a more complete and detailed list, see overview of key features. So, I don't think that this is the best use of my time to read all these currently. So I'm going to move on to the next section, which let's read this to see if I need to read this. Snowflake releases. Snowflake is committed to providing a seamless, always up-to-date experience for our users, while also delivering ever-increasing value through rapid development and continual innovation. To meet this commitment, we deploy new releases each week. This allows us to regularly deliver service improvements in the form of new features, enhancements, and fixes. The deployments happen transparently in the background. Users experience no downtime or disruption of service and are always assured of running on the most recent release with access to the latest features. This topic describes the processes we follow for weekly releases, including the option to request 12-hour early access for Enterprise Edition and Business Critical Edition accounts, or 24-hour early access for virtual private Snowflake accounts to enable additional release testing if desired. So, I think that this is not necessary for me to read right now. Overview of key features. This topic lists the notable/significant features supported in the current release. Note that it does not list every feature provided by Snowflake. I guess I'll read this page. It seems relevant. Security, governance, and data protection. Choose the geographical location where your data is stored based on your region. User authentication through standard user password credentials. Enhanced authentication with multi-factor authentication. Federated authentication and single sign-on. Snowflake OAuth, external OAuth. All communication between clients and the server protected through TLS. Deployment inside a cloud platform, VPC, AWS or GCP or VNet Azure. Isolation of data for loading and unloading using Amazon S3 policy controls. Support for PHI data in compliance with HIPAA and high trust CSF regulations. Automatic data encryption by Snowflake using Snowflake managed keys. Object level access control. Snowflake time travel, 1 day standard for all accounts. Additional days up to 90 allowed with Snowflake Enterprise for querying historical data in tables. Restoring and cloning historical data in databases, schemas, and tables. Snowflake failsafe, 7 day standard for all accounts for disaster recovery of historical data. Column level security to apply masking policies to columns in tables or views requires Enterprise Edition or higher. Row level security to apply row access policies to tables and views. Object tagging to apply tags to Snowflake objects to facilitate tracking sensitive data and resource usage. Standard and extended SQL support. Most DDL defined in SQL 1999, including databases, schemas, tables, and related objects, core data types, set operations, cast functions. Standard DML such as update, delete, and insert, as well as more advanced DML, multi-table insert, merge, and multi-merge. DML for bulk data loading and unloading. Iceberg tables, transactions, temporary and transient tables for transitory data, lateral views, materialized views, statistical aggregate functions, analytical aggregates, group by cube, rollup, and grouping sets, parts of the SQL 2003 analytic extensions, windowing functions, grouping sets, scalar and tabular user-defined functions, UDFs, with support for Java, JavaScript, Python, Scala, and SQL, stored procedures and procedural language support, Snowflake scripting, Snowflake information schema for querying object and account metadata, as well as querying warehouse usage history data, recursive queries including connect by, recursive CTE, common table expressions, collation support, geospatial data support, tools and interfaces, Snowsight for account and general management, monitoring of resources and system usage, and querying data, SnowSQL, Python-based command line client, virtual warehouse management from the GUI or command line, including creating, resizing with zero downtime, suspending and dropping warehouses, Snowflake extension for Visual Studio Code, detailed instructions for installing, configuring, and using the Snowflake extension for Visual Studio Code, apps and extensibility, APIs for Java, Python, and Scala, with which you can build applications that process data in Snowflake without moving data to the system where your application code runs, a framework for creating applications to share data content and an application logic with other Snowflake accounts, a RESTful API for accessing and updating data, support for running Streamlit apps natively in Snowflake to create and share custom web apps for machine learning and data science, extensive set of client connectors and drivers provided by Snowflake. Snowpark Container Services is a fully managed container offering that helps you easily deploy, manage, and scale containerized applications. Connectivity, broad ecosystem of supported third-party partners and technologies, support for using free trials to connect to selected partners, data import and export, support for bulk data loading and unloading data into out of tables, including load any data that uses a supported character encoding, load data from compressed files, load most flat delimited data files, CSV, TSV, etc., load data files in JSON, Avro, ORC, Paracut, and XML format, load from files in cloud storage or local files using the Snowflake web interface or command line client, support for continuous data loading from files, use Snowpipe to load data in micro batches from internal, i.e. Snowflake stages, or external Amazon S3 stages, support for accessing data in S3 compatible storage, data sharing, support for securely sharing data with other Snowflake accounts, provide data to other accounts to consume data provided by other accounts, replication and failover, support for replication and failover across multiple Snowflake accounts in different regions and cloud platforms, replicate objects between Snowflake accounts within the same organization, and keep the objects and stored data synchronized, configure failover to one or more Snowflake accounts for business continuity and disaster recovery. So on to data management with the data lifecycle. Snowflake provides support for all standard select DDL and DML operations across the lifecycle of data in the system, from organizing data and storing data to querying and working with data, as well as removing data from the system. Lifecycle diagram. All user data in Snowflake is logically represented as tables that can be queried and modified through standard SQL interfaces. Each table belongs to a schema, which in turn belongs to a database. So here we see the Snowflake database lifecycle: organizing data, create database, alter database, create schema, alter schema, create table, alter table, storing data, insert into table, copy into table, querying data, select from table, working with data, update table, merge into table, delete from table, create table clone, create schema clone, create database clone, and removing data, truncate table, drop schema, drop database. Organizing data. You can organize your data into databases, schemas, and tables. Snowflake does not limit the number of databases you can create or the number of schemas you can create within a database. Snowflake also does not limit the number of tables you can create in a schema. For more information, see all of these. Storing data. You can insert data directly into tables. In addition, Snowflake provides DML for loading data into Snowflake tables from external formatted files. For more information, see insert copy into table. Querying data. Once data is stored in a table, you can issue select statements to query the data. Working with data. Once data is stored in a table, all standard DML operations can be performed on the data. In addition, Snowflake supports DDL actions such as cloning entire databases, schemas, and tables. For more information, see those. Removing data. In addition to using the DML command delete to remove data from a table, you can truncate or drop an entire table. You can also drop entire schemas and databases. For more information, see those. Continuous data protection encompasses a comprehensive set of features that help protect data stored in Snowflake against human error, malicious acts, and software failure. At every stage within the data lifecycle, Snowflake enables your data to be accessible and recoverable in the event of accidental or intentional modification, removal, or corruption. The features include network policies for granting or restricting users access to the site based on their IP address, i.e. IP allow lists, verification/authentication required for any users accessing your account, include support for MFA and SSO, security roles for controlling user access to all objects in the system. All files stored on internal stages for data loading and unloading operations are automatically encrypted using AES 256 strong encryption on the server side. By default, Snowflake provides additional client-side encryption with a 128-bit key, with the option to configure a 256-bit key. Maintenance of historical data, i.e. data that has been changed or deleted through Snowflake time travel for querying and restoring data, and failsafe for disaster recovery can only be performed by Snowflake. Most continuous data protection features are included standard for all Snowflake editions. However, some features are available only for Snowflake Enterprise Edition or higher. In addition, both time travel and failsafe require additional data storage, which has associated fees. And let's go to now compliance, regulatory compliance. Snowflake is committed to meeting industry standard regulatory compliance requirements to provide our customers the highest level of assurance for data integrity, security, and governance. This topic is referenced for Snowflake certifications based on geographic regions. And now we made it through the concepts section. So let's move to tutorials. To explore the tutorials listed below, you must have an account and a user with required roles and access to a virtual warehouse. Okay. So for new users, Snowflake in 20 minutes. This is a simple tutorial in which you use SnowSQL, the Snowflake command line client, to learn about key concepts and tasks. Let's jump into it. Real quick. No, let's keep going. So, introduction. This tutorial uses the Snowflake command line client, SnowSQL, to introduce key concepts and tasks, including creating Snowflake objects. You create a database and a table for storing data. Loading data. We provide small sample CSV data files for you to load into the table. Querying. You explore sample queries. Note, Snowflake bills a minimal amount. I'm not too worried about that. What you'll learn. In this tutorial, you'll learn how to create Snowflake objects. You create a database and a table for storing data. Install SnowSQL. You install and use SnowSQL, the Snowflake command line query tool. Users of Visual Studio Code might consider using the Snowflake extension for Visual Studio Code instead of SnowSQL. Load CSV data files. You use various mechanisms to load data into tables from CSV files. Write and execute sample queries. You write and execute a variety of queries against newly loaded data. Prerequisites. This tutorial requires a database, table, and virtual warehouse to load and query data. Creating these Snowflake objects requires a Snowflake user. Got you. In addition, SnowSQL is required to execute the SQL statements in the tutorial. Lastly, the tutorial requires CSV files that contain sample data to load. You can complete this tutorial using an existing Snowflake warehouse, database, and table, and your own local data files, but we recommend using the Snowflake objects and the set of provided data. To set up Snowflake for this tutorial, complete the following before continuing. So I already created an account, and now it's time to install SnowSQL. They said it would be 20 minutes. So, is that not part of it? Well, it's just to complete it before continuing, so I guess let's do this then. So, installing SnowSQL. This topic describes how to download and install SnowSQL on all supported platforms. To download the SnowSQL installer, go to the SnowSQL download page for Mac OS. So, installing SnowSQL on Mac OS. This section describes how to download and run the installer package to install SnowSQL on Mac OS. Setting the download directory and configuration file location by default. The SnowSQL installer downloads the binaries to the following directory. So, put that right here. Let's run this package. Install for all users. Okay. Congratulations, installation complete. Complete the following steps. Open a new terminal window. Execute the following command to test your connection. So, my account name. All right, well, what's my account name? Let's figure that out. So I'm not sure if that's my username. What's the difference between my account name and my login name? Well, let's go to accounts. Gonna assume that's my account name. And then my login name. Gonna assume that's this. Okay. Let's hope those are fair assumptions to make. Okay. Well, let's see what this is telling me to do. So by default, the SnowSQL installer downloads the binaries to the following directory. Consequently, the configuration file is located under the download directory. You can change both the download directory and location of the configuration file by setting the workspace environment variable to any user writable directory. This is particularly useful if you have an isolated SnowSQL environment for each process. In addition, you can separate the download directory from the configuration file by setting the SnowSQL download dir environment variable so that multiple SnowSQL processes can share the binaries. For example, SnowSQL download dir equals var shared SnowSQL-h. Note that SnowSQL download dir is supported starting with the SnowSQL 1.1.70 bootstrap version. To check the version you're using, execute the following command. So to download the SnowSQL installer, go to the download page. Using curl to download the installer. So configuring the Z shell alias macOS only. If Z shell, also known as ZSH, is your default terminal shell, set an alias to the SnowSQL executable so that you can run SnowSQL on the command line in terminal. The SnowSQL installer installs the executable application snowsql.app contents macOS SnowSQL and appends this path to the path or alias entry in profile. Because ZSH does not normally read this file, add an alias to this path in ZSHRC, which ZSH does read. To add an alias to the SnowSQL executable, open or create if missing the ZSHRC file, add the following line. Okay, so for right now, I know this is not going to be very interesting, but I'm just going to hide screen capture right now so you get to see my face while I deal with my files. So So, okay. Um, mm, just for full transparency, right? So, bring this back in. So, all I did, just in case anybody wants to know, is I pulled up the file from the terminal and I copy pasted this line right here to the end. I don't think this is really sensitive information I have here, so now just save the file. Um, wrong one. Okay. Webcam, screen capture, cool. So I got all that set. I ran source, so now it should be active, and we should be good. Hopefully we are good. We'll find out soon. So back to the prerequisites. Can you see this? Yeah, you can see. Okay. So now I've installed Snowflake. Download sample data files. For this tutorial, you download sample employee data files in CSV format that Snowflake provides. To download and unzip the sample data files, download the set of sample data files, right-click the name of the archive file. You know, certain things that are difficult when I'm learning while streaming, like dealing with my files and all that. But this is truly the best way that I learn, just saying things out loud and having this necessity to not get distracted because I know I'm being recorded. So this really truly might not be the most entertaining next couple of seconds or minute, but just give me a minute. Let me just figure this out. Okay. So I think it should be configured right now. I downloaded it, unzipped it to this temp directory. Now I'm in the temp directory. So each file has 5 data records. Data uses a comma character as field delimiter. The following is an example record. Althea Featherstone, a Featherstone at sftuts.com with an address, Caltrava 7 and a date. There are no blank spaces before or after the comma separating the fields in each record. This is the default Snowflake expects when loading CSV data. Great. So after you have SnowSQL, start SnowSQL to connect to Snowflake. Open a command line window, start SnowSQL. Account identifier is the unique identifier for your Snowflake account. Before format for your account identifier is as follows. Well, let's read this, right? Even though it's a lot, let's read it. So, account identifiers. An account identifier uniquely identifies a Snowflake account within your organization, as well as throughout the global network of Snowflake-supported cloud platforms and cloud regions. The preferred account identifier includes the name of the account along with its organization, e.g. MyOrg account 123. Although you can also use the Snowflake assigned locator as the account identifier, the use of this legacy format is discouraged. Where are account identifiers used? Account identifiers are required in Snowflake wherever you need to specify the account you're using, including URLs for accessing any of the Snowflake web interfaces, SnowSQL and other clients, connectors, drivers, etc. for connecting to Snowflake, third-party applications and services that comprise the Snowflake ecosystem, security features for protecting Snowflake internal operations and communication/interaction with external systems, global features such as secure data sharing and replication and failover/failback. For example, the URL for an account uses the following format: accountidentifier.snowflakecomputing.com. If your organization uses the client redirect feature, the name of a connection object can be used in place of the account name in the account identifier to connect to a Snowflake account using a Snowflake client. For more information, see using a connection URL. For more information about using account identifiers and connections to connect to a Snowflake account, see connecting to your accounts. Format 1, preferred account name in your organization. An organization is a Snowflake object that links the accounts owned by your business entity. Organizations enable organization administrators, i.e. users with the org admin role, to view, create, and manage all of your accounts across different cloud platforms and regions. Account names must be unique within your organization and can be changed, which allows more flexibility and leads to shorter and more intuitive account names. You specify an account name when you create a new account. See creating an account. To change a name for an existing account, see renaming an account. While an account name uniquely identifies an account within your organization, it is not a unique identifier of an account across Snowflake organizations. Account names with underscores also have a dashed version of the URL for features that do not accept URLs with underscores, such as Okta, SSO, SCIM. Use an account name as an identifier. The account identifier for an account in your organization takes one of the following forms, depending on where and how the identifier is used: org name - account name for most URLs and other general purpose usage, org name - account name for scenarios. How is that different? Oh, I see. One has an underscore, one has a dash. And then there's a dot for SQL commands and operations, where org name is the name of your Snowflake organization. Account name is the unique name of your account within your organization. Finding the organization and account name for an account. Find the account name for an account. You can use Snowsite or SQL. Snowsite, one, open the account selector and review the list of accounts that you previously signed into. So we click on that and then account. Okay. So in this case, it seems like okay. So M is my organization, and it looks like this is my account name. So back here, to locate the account for which you want to copy the account name. Hover over the account to view additional details, and then select the copy icon to copy the account identifier. Oh, okay, so I could just do that. Which is where? I have to hover over it. Got you. Cool. So, so it looks like it wants me to use it with the dash format. So where account identifier is the unique identifier for your Snowflake account. The preferred format for the account identifier is as follows: organization name dash account name, names of your Snowflake organization and account. For more information, see that. Username is the login name for your Snowflake user. Note, if your account has an identity provider, IDP, that has been defined for your account, you can use a web browser to authenticate instead of a password, as the following example demonstrates. When using SnowSQL prompts, enter the password for your Snowflake user. If you log in successfully, SnowSQL displays a command prompt that includes your current warehouse, database, and schema. So try it again. I didn't use the dash format. That's exactly what I was trying to avoid. It's okay though. Let's just paste all of it and then come back here. Cool. So we see the username, # with compute, WH app, no database, no schema. Create Snowflake objects. During this step, you create the following Snowflake objects: a database, sftuts, and a table, emp basic. You load sample data into this table. A virtual warehouse, sftuts, WH. This warehouse provides the compute resources needed to load data into the table and query the table. At the completion of this tutorial, you will remove these objects. Create the sftuts database using the create database command. So we'll create the sftuts database using the create database command. Create or replace database sftuts. In this tutorial, you use the default schema public available for each database rather than creating a new schema. Note that the database and schema you just created are now in use for your current session as reflected in the SnowSQL command prompt. You can also use the context functions to get this information. So we see database sftut successfully created. 1 row is produced. Now we see we're using this. You can also use the context functions to get this information. Following is an example results. So let's try using these. We see current database sftuts, current schema public, create a table. Create a table. Let's move this a little bit so this takes up more space on the screen. Keep it like that for now. Create a table named emptBasic in sftuts.public using the create table command. First name string, last name string, email string, street address string, city string, start date as date. Great. Table empbasic successfully created. Note that the number of columns in the table, their positions, and their data types correspond to the fields in the sample CSV data files that you stage in the next step in this tutorial. Create a virtual warehouse. Create an XML warehouse named sftuts.wh using the create warehouse command. Warehouse size equals x small, auto suspend equals 180, auto resume equals true, initially suspended equals true. The warehouse was successfully created. The sftuts.wh warehouse is initially suspended, but the DML statement also sets auto resume equals true. The auto resume setting causes the warehouse to automatically start when SQL statements that require compute resources are executed. After you create the warehouse, it's now in use for your current session. This information is displayed in your SnowSQL command prompt. You can also retrieve the name of the warehouse by using the following context function. Nice. Stage data files. Let me check something real quick. 1212. Okay, cool. So, a Snowflake stage is a location in cloud storage that you use to load and unload data from a table. Snowflake supports the following types of stages. Internal stages, used to store data files internally within Snowflake. Each user and table in Snowflake gets an internal stage by default for staging data files. External stages, used to store data files externally in Amazon S3. If your data is already stored in these cloud storage services, you can use an external stage to load data in Snowflake tables. In this tutorial, we upload the sample data files to the internal stage for the emp basic table that you created earlier. You use the put command to upload the sample data files to the stage. Staging sample data files, execute the put command in SnowSQL to upload local data files to the table stage provided for the emp basic table you created. Just making sure I got all that right. Looks good to me. Before I hit enter, let's take a closer look at the command. This specifies the full directory path and names of the files on your local machine to stage. Note that the file system wildcards are allowed, and if multiple files fit the pattern, they're all displayed. This indicates to use the stage for the specified table, in this case the emp basic table. The command returns the following result showing the stage files. Nice. So if I expand it a little bit, we have source, these CSVs, target, these, source size, target size, source compression, none, target compression, gzip, status uploaded. 5 rows produced, great. The put command compresses files by default using gzip as indicated in the target compression column. Listing the stage files optional. You can list the stage files using the list command. Let's try it out. List as a tuts.public %, emp basic, and we see a similar output. Copying data into target tables. To load your stage data into the target table, execute copy into table. The copy into table command uses the virtual warehouse you created in create Snowflake objects to copy files. So we see I'm just wondering if I messed up somewhere because of the color, right? Did I mess up? Looks right. Well, I'll type it all out and then probably copy paste it just to be sure. This might be me exposing myself because there's probably a simpler way to do this, but this is what I always have to do. Okay, yeah, no, I think I did it right the first time. Cool. And nice. So the from clause specifies the location containing the data files, the internal stage for the table. So we did from at %m basic. The file format clause specifies the file type as CSV and specifies the double quote character as the character used to enclose strings. Snowflake supports diverse file types and options. These are described in create file format. The pattern clause specifies that the command should load data from the file names matching this regular expression. The onError clause specifies what to do when the copy command encounters errors in the files. By default, the command stops loading data when the first error is encountered. This example skips any file containing an error and moves on to loading the next file. None of the files in this tutorial contain errors. This is included for illustration purposes. The copy command also provides an option for validating files before they're loaded. For more information about additional error checking and validation instructions, see the copying to table topic and the other data loading tutorials. The copy command returns a result showing the list of files copied and related information. So here we see the files loaded, rows parsed, rows loaded, error limit, error seen, first error line, first error character, first error column name. So we're good, no errors. Query loaded data. You can query the data loaded in the basic table using standard SQL and any supported functions and operators. You can also manipulate the data, such as updating the loaded data or inserting more data using standard DML commands. Retrieve all data, return all rows and columns from the table. Select all from basic. Nice. Insert additional data rows. So just to go over it, we have the first name, last name, email, street address, city, and start date with 25 rows. So to insert data rows, in addition to loading data from stage files into a table, you can insert rows directly into a table using the insert DML command. For example, to insert 2 additional rows into the table. Fine, I'm not going to type all this out. Query rows based on email address. Return a list of email addresses with United Kingdom top-level domains using the not-like function. So select email from basic where email like .uk. And we see these 3 emails that end in .uk. Query rows based on start date. For example, to calculate when certain employee benefits might start, add 90 days to employee start dates using the dateAdd function. Filter the list by employees whose start date occurred earlier than January 1st, 2017. So select first name, last name, date add, day, 90, start date, from basic where start date less than or equal to 2017 01. And we see now Granger Basford 2017 0330 and a couple other rows. Nice. Summary, cleanup, and additional resources. Congratulations, you successfully completed this introductory tutorial. Take a few minutes to review a short summary and the key points covered in the tutorial. You might also want to consider cleaning up by dropping any objects you created in the tutorial. Learn more by reviewing other topics in the Snowflake documentation. Summary and key points. In summary, data loading is performed in 2 steps. First, stage the data files to load. Files can be staged internally in Snowflake or in an external location. In this tutorial, you stage files internally. 2. Copy data from the stage files into an existing target table. A running warehouse is required for this step. Again, stage the data files to load. The files can be staged internally in Snowflake or in an external location. In this tutorial, you stage files internally. And then 2, copy data from the stage files into an existing target table. A running warehouse is required for this step. Remember the following key points about loading CSV files. A CSV file consists of one or more records with one or more fields in each record and sometimes a header record. Records and fields in each file are separated by delimiters. The default delimiters are records, new line characters, fields, commas. In other words, Snowflake expects each record in a CSV file to be separated by new lines and the fields, i.e. individual values in each record, to be separated by commas. If different characters are used as record and field delimiters, you must explicitly specify this as part of the file format when loading. There is a direct correlation between the fields in the files and the columns in the table you will be loading in terms of number of fields in the file and columns in the target table, positions of the fields and columns within their respective file/table, data types such as string, number, or date for fields and columns. The records will not be loaded if the numbers, positions, and data types don't align with the data. Note, Snowflake supports loading files in which the fields don't exactly align with the columns in the target table. However, this is a more advanced data loading topic covered in transforming data during a load. Tutorial cleanup optional. If the objects you created in this tutorial are no longer needed, you can remove them from the system with drop object statements. So, status drop statement executed successfully. Cool. Exit the connection. To exit a connection, use the exclamation exit command for SnowSQL or its alias exclamation disconnect. Exit drops the current connection and quit SnowSQL if it is the last connection. So cool. What's next? Continue learning about Snowflake using the following resources. Complete the other tutorials provided by Snowflake. Familiarize yourself with key Snowflake concepts and features, as well as the SQL commands to perform queries and insert update data. So what else is there? So that was for new users, Snowflake in 20 minutes, a simple tutorial in which you use SnowSQL, command line client, to learn about key concepts and tasks. For tutorials that are available with a trial account, consider create users and grant roles, load and query sample data using SQL, load and query sample data using Snowpark Python, load data from cloud storage, Amazon S3. For tutorials on bulk loading, consider bulk loading from a local file system, bulk loading from Amazon S3. To explore semi-structured data, consider JSON basics, loading JSON data into a relational table, loading and unloading Parquet data. So, whoa. I think this relates to how they said you should probably be using Google Chrome, huh? Well, this seems like it works. I don't know if I'm gonna actually finish all this. How long is this gonna take? Doesn't seem that long, actually. Alright, so introduction. This tutorial uses a fictitious food truck brand named Tasty Bites to show you how to load and query data in Snowflake using SQL. You use a preloaded worksheet in Snowsight to complete these tasks. The following illustration provides an overview of Tasty Bites. Who is Tasty Bites? About us. Global food truck network, localized menu options, 15 countries, 30 major cities, and 15 core brands. Okay, they have a mission and they have a vision and some locations served and the current state and future goals. Great, they have 450 current food trucks. Okay, gotcha. Note, Snowflake bills a minimal amount for the on-disk storage used for the sample data in this tutorial. The tutorial provides steps to drop the database and minimize storage cost. Snowflake requires a virtual warehouse to load the data and execute queries. Running virtual warehouse consumes Snowflake credits. In this tutorial, you'll be using a 30-day trial account, which provides free credits, so you won't incur any costs. What you will learn. In this tutorial, you will learn how to use a role to get access to functionality from granted privileges, use a warehouse to access resources, create a database and schema, create a table, load data into the table, query the data in the table. So prerequisites. This tutorial assumes the following. You have a supported browser, you have a trial account, your user is the account administrator and is granted the account admin system role. For more information, blah, blah, blah. Note this tutorial is only available to users. Gotcha. So sign in using Snowsite to access Snowsite over the public internet. Do the following. Done. Provide your account identifier. Gotcha. Open the SQL worksheet for loading and querying data. So projects, worksheets. Select projects or worksheets to open the list of worksheets. Open tutorial using SQL to load and query sample data. What was it called again? Worksheets. Load sample data with SQL from S3 bucket. That's not this one. Template, adding a user and granting roles. Getting started tutorial, sample queries. I don't see it. Did I accidentally delete it or something? Okay. But I'm not trying to do it from a well, this one says from S3 bucket, but I don't. Guess let's follow along until we can't. So, your worksheet looks similar to the following image. Set the role and warehouse to use. The role you use determines the privileges you have. In this tutorial, you use the account admin system role so that you can view and manage objects in your account. For more information, see using the account admin role. A warehouse provides the required resources to create and manage objects and run SQL commands. These resources include CPU, memory, and temporary storage. Your trial account has a virtual warehouse, compute WH, that you can use for this tutorial. For more information, see virtual warehouses. To set the role and warehouse to use, do the following. In the open worksheet, place your cursor in the use role line. Oh, I see. Use role account admin. In the upper right corner of the worksheet, select run. Note in this tutorial, run SQL statements one at a time. Do not select run all. Okay. So my cursor is here. Run. Place your cursor in the use warehouse line so statement executes successfully. Great. Use warehouse line. Then select run. Nice. Step 4, create a database schema and table. A database stores data in tables that you can manage and query. A schema is a logical grouping of database objects such as tables and views. For example, a schema might contain the database objects required for a specific application. For more information, see Databases, Tables, and Views Overview. In this tutorial, you create a database named Tasty Bites Sample Data, a schema named Raw Pause, and a table named Menu. To create the database schema and table, do the following. In the open worksheet, place your cursor in the Create or Replace Database line. Select Run. Place your cursor in the Create or Replace Schema line and select Run. Place your cursor in the Create or Replace Table lines and select Run. confirm that the table was created successfully, place your cursor in the select line and select run. Your output shows the columns of the table you created. Do I need to select all of these? Oh, okay. The table does not have any rows. Good. Create a stage and load the data. A stage is a location that holds data files to load into a Snowflake database. This tutorial creates a stage that loads data from an Amazon S3 bucket. This tutorial uses an existing bucket with a CSV file that contains the data. You load the data from this CSV file into the table you created previously. For information, see bulk loading for Amazon S3. To create a stage, do the following. In the open worksheet, place your cursor in the create or replace stage lines and select run. To confirm that the stage was created successfully, place your cursor in the list line, then select run. Your output looks similar to the following image. Yes, it does. To load the data into the table, place your cursor into the copy into lines and select run. Query the data. Now that the data is loaded, you can run queries on the menu table. To run a query in the open worksheet, select the line or lines of the select command and then select run. For example, to return the number of rows in the table, run the following query. How many rows are in the table? Select count all as row count from tastybytes sample data.rawpause.menu. Output looks similar to the following image. Run this query to return the top 10 rows in the table. Select top 10 all from tastybytes sample data. Gotcha. Cool. Output looks similar to the following image. For more information about running a query that returns a specified number of rows, see top N. You can run other queries in the worksheet to explore the data in the menu table. Cleanup, summary, and additional resources. Congratulations, you've successfully completed this tutorial for trial accounts. Take a few minutes to review a short summary and the key points covered in this tutorial. Consider cleaning up by dropping any objects you created in this tutorial. Learn more by reviewing other topics in the Snowflake documentation. Cleaning up tutorial objects optional. If the objects you created in this tutorial are no longer needed, you can remove them from the system with drop object commands. To remove the database you created, run the following command. Drop database if exists. So just checking this out. You could also do what menu items does the freezing point brand sell. You could do select menu item name from tastybytes sample data raw pause menu where truck brand name freezing points. Let's try running that. So we see the menu items. What is the profit on mango sticky rice? We could do select menu item name, sale price USD minus cost of goods USD as profit USD from tastybytes sample data raw pause menu where 1 equals 1 and truck brand name equals freezing point and menu item name equals mango sticky rice. And that was the profit on mango sticky rice. It is the profit, 375. To finish, let's extract the mango sticky rice ingredients from the semi-structured column. Select m.menu item name, object.value ingredients, array as ingredients from tastybytes, sample data.rawpause.menu m, lateral flatten input m.menu item health metrics obj, menu item health metrics obj, where 1 equals 1 and truck brand name equals freezing point and menu item equals mango sticky rice. This is showing us the ingredients: sweet mango, sticky salted rice, coconut milk, and sesame seeds. Sounds delicious. Alright, but now let's drop this. So I misspelled it. Drop database if exists, tastybytes Sample data. Run it. Tasty Bites sample data successfully dropped. Summary and key points. In summary, you used a preloaded worksheet in Snowsite to complete the following steps. Set the role and warehouse context, create a database schema and table, create a stage, and load the data from the stage into the database, query the data. Here are some key points to remember about loading and querying data. You need the required permissions to create and manage objects in your account. In this tutorial, you use the account admin system role for these privileges. This role is not normally used to create objects. Instead, we recommend creating a hierarchy of roles aligned with business functions in your organization. For more information, see using the account admin role. You need a warehouse for the resources required to create and manage objects and run SQL commands. This tutorial uses the compute WH warehouse included with your trial account. You created a database to store the data and a schema to group the database objects logically. You created a stage to load data from a CSV file. After the data was loaded into your database, you queried it using select statements. What's next? You could complete other tutorials provided by Snowflake, familiarize yourself with key Snowflake concepts and features, as well as the SQL commands used to perform queries and insert update data. Try the Tasty Bites quick starts provided by Snowflake. Okay, I feel like some good progress was made here. I'm going to call that for right now, but there's going to be more of this as I get myself more and more familiar with the platform.